For his uncommon obligation to the fields of material science, Michio Kaku has actually asserted that the James Webb Space Telescope has seen 6 enormous frameworks that specialists thought couldn't exist. These assessments have the potential to open up new viewpoints in our understanding of the universe. The revelation is both empowering and progressive, testing existing hypotheses about the development and advancement of galaxies. It is, therefore, worth keeping an eye out for these upgrades. The confirmation by such a recognized specialist highlights the importance of these disclosures. Michio Kaku is a surprising figure in the scientific field, a physicist of American and Japanese heritage. He is viewed as an expert in both traditional exploratory material science and quantum mechanics. Unlike some more conservative and dubious specialists, Kaku has been receptive to the astounding delayed consequences of the James Webb Space Telescope mission. His enthusiasm to embrace new discoveries and share them with the public showcases his commitment to advancing our understanding of the universe. We are satisfied that this recognized scientist has decided to end his silence and transparently share what can no longer be denied. The energy and almost focused tone of the popular, magnificent physicist are clear in his comments on the discovery made by the James Webb Space Telescope, indicating that this has been a feature that has sparked his interest. Join us to explore the implications of Michio Kaku's divulgence of these 6 huge frameworks. Kaku is a researcher who has always been able to contemplate new theories. Throughout his life, he has shown a responsiveness to ideas that challenge the status quo, realizing that Einstein's theories of relativity and Newton's laws, while fundamental, are insufficient to explain the full complexity of the universe. Kaku appreciates that the discoveries of the new telescope have the potential to advance the field of cosmology, but many of his colleagues have yet to adopt this view. This has caused concern and sleeplessness among the Big Bang proponents and critics of quantum mechanics. However, this just incites laughter from Kaku. The JWST has revealed the discovery of 6 colossal galaxies dating back to the earliest times of the universe. Each of these grandiose galaxies contains more stars than our own Milky Way, despite having formed only 200 to 700 million years after the Big Bang. The team of space scientists who made the discovery has named these phenomenal galaxies universe breakers, since, if confirmed, they would radically change our understanding of the universe. The consequences of these discoveries are significant, suggesting that the universe's early years were much more robust and complex than previously thought. Something doesn't fit here anymore. The theory of how things came to be tells us that the universe was chaotic after the initial event. The first solid objects took a vast number of years to form, and it took even more years for these objects to reach sufficient density and produce light. The formation of complex structures like galaxies was assumed to happen much later. Some of the newly found galaxies outshine the Milky Way in size, and their immense brightness suggests that they were likely forming many new stars every year, while our galaxy forms stars intermittently. It remains unclear precisely when the first galaxies formed. Scientists have not yet determined this. The only clear thing is that at first, there might have been only single stars or groups of stars, which eventually combined to form larger structures until dwarf galaxies fostered small cosmic frameworks that evolved over time. Incredibly large and massive galaxies were thought to be incapable of existing at that time, which raises the question of whether the universe is much older than recently acknowledged, or whether complex astronomical structures formed much sooner. This situation is hard to accept for conservative science, which still finds issues with this model. Several aspects of physics have explicitly rejected this discovery and questioned possible errors in the age estimates. Kaku is aware of this and had this to say. There are numerous models of old and misleading theories that stubbornly persist due to the influence of certain specialists. Many of these theories were only exposed when significant research revealed their flaws. Therefore, the key word in any science, especially in physics, rests with the experimentalists who keep the researchers alert and aware. In fact, on Earth, we have barely any knowledge about the actual origins of the universe. This statement from Kaku highlights the importance of continuous experimentation and validation in the scientific process. The theory of how things came to be was established in 1927 based on observations of the expansion of the universe. This data led to the conclusion that the universe began from a specific point and has been expanding ever since. At the time, it was hard for people and scientists to imagine a universe with both a beginning and an end. The idea of a universe that had always existed and was infinite in scope was beyond human imagination. Even today, scientists still struggle to understand it. However, it is essential to consider these possibilities, even if these new discoveries don't align with what researchers have assumed for years regarding the Big Bang Theory. Science has shown time and again that reevaluation and openness to new ideas are integral parts of the scientific process. Just like the acceptance of certain theories and observations, when Einstein was young, it was once accepted that stars and planets were firmly fixed in the universe and that these specific arrangements occupied a defined space. However, we now know that everything in the universe is in motion. Planets orbit stars, stars move within their galaxies at speeds of several kilometers per second, and entire galaxies move rapidly through the cosmos, whose fate we still cannot predict. This exceptional understanding of the universe challenges long-held beliefs and underscores the need for continuous inquiry and change in scientific thought. Today, scientists are challenged to accept uncomfortable insights and understand that theories are not absolute truths until they are fully tested or confirmed by accurate observation. The concept of the Big Bang arose from the realization that galaxies are moving away from each other, and this distance is proportional to their separation from Earth. This observation, known as Hubble's law, proposed that the universe was expanding over time. Elements such as cosmic background radiation and the redshift of light from distant galaxies, along with other cosmological patterns, appear to support this theory. However, it is important to remember that in the past, people who believed the Earth was flat and that the Sun revolved around us also had observational evidence for their beliefs, until new events or technological advancements came along that provided a clearer picture. Right now, we are seeing a similar situation. Scientists expected the new James Webb Space Telescope to confirm doubts related to the Big Bang. However, instead, they have encountered these 6 galaxies that appeared impossible. This shows that science is constantly evolving, and that scientists must remain open to new discoveries and reconsider existing theories based on available evidence. The surprising discoveries challenge current understanding and prompt a reassessment of long-standing cosmological hypotheses. Researchers use redshift as a tool to determine various metrics in the study of the universe. Redshift, also known as the Doppler effect, refers to the change in the color of light as light sources and observers move relative to one another. To understand this, imagine standing still and hearing a car approaching you. As the car moves closer, the engine sound gets louder. However, when the car passes you or moves away, the engine sound changes. This is because the sound waves change as the vehicle moves. The same is true for light. When a light source, such as a distant star, moves toward us, the light shifts to bluer tones. Conversely, when the light source moves away, the light shifts to redder tones. This phenomenon is called redshift. Physicists have converted redshift values into rates and distances for measurement in the study of the universe. However, it is crucial to note that even a small error in these measurements can have significant impacts. The measurement methods previously used are now under review. The latest discoveries related to our universe require consideration of whether they are truly based on redshift mistakes or whether some scientists are simply denying the facts. This is a question that requires careful investigation and a thorough review of the data and methods used in the research. The ongoing investigation and reassessment of measurement techniques highlight the evolving nature of scientific inquiry. Many thanks for watching the video. As always, we remind you to post your inquiries in the comments section. If you enjoyed the video, make sure to hit the like button, share it so it reaches more people, and subscribe to the feed so you don't miss more content like this. Thanks for watching, and see you in the next one. This call to action encourages viewers to engage with the content, fostering a community of curious minds eager to explore and grasp the latest scientific discussions. The exploration of our universe, with its vast distances and complex celestial bodies, continues to fascinate and challenge scientists across the globe. From early theories about the universe to the latest discoveries made possible by cutting-edge technology, every discovery reshapes our understanding of the universe and stretches the boundaries of human knowledge. One of the most significant and persistent questions in cosmology revolves around the origin and evolution of galaxies. Galaxies are like cities of stars, gas, dust, and dark matter bound together by gravity. Understanding how galaxies form and evolve is crucial not only for unraveling the mysteries of our universe, but also for confirming or testing existing theories, such as the theory of the universe's origin. The Big Bang Theory, proposed nearly a century ago, suggests that the universe began from a single, infinitely dense point and has been expanding ever since. This idea arose from observations of the universe's expansion and the cosmic microwave background radiation, considered the remnants of the early universe's intense heat and light. However, recent discoveries, particularly those made by the James Webb Space Telescope, JWST, have challenged several key assumptions underlying the Big Bang Theory. The JWST, with its remarkable sensitivity and resolution, has identified galaxies that appear far more massive and advanced than expected for their age. One such discovery involves 6 massive galaxies dating back to when the universe was only 200 to 700 million years old, a mere blink in its 13.8 billion-year history. These galaxies, named universe breakers by the research team, challenge conventional understanding because they are already so large and luminous at such an early cosmic age. The discovery of these galaxies raises intriguing questions about the rapid development of the early universe and challenges existing models of galaxy formation. According to prevailing theories, galaxies formed slowly over billions of years through the merging of smaller structures and the accumulation of gas and stars. The existence of these massive galaxies so early in cosmic history suggests a much more complex and potentially faster process of galaxy development than previously thought. Additionally, the discovery highlights the significant role of technological advancements in reshaping our understanding of the universe. The JWST's ability to peer deeper into space and capture faint light from distant galaxies has allowed astronomers to uncover previously invisible aspects of the universe's early evolution. These observations provide valuable insights into the conditions and processes that governed galaxy formation during the universe's infancy. The implications of these discoveries extend beyond cosmology. They challenge scientists to revisit and refine existing cosmological models to better account for the observed diversity and complexity of galaxies across cosmic time. They also underscore the dynamic and evolving nature of scientific knowledge, where new discoveries can prompt paradigm shifts and open new avenues for investigation. As scientists continue to analyze and interpret the data from the JWST and other observatories, the study of galaxy formation remains a vibrant and growing field of research. Each new discovery brings us closer to unraveling the mysteries of our cosmic origins and understanding the key processes that have shaped the universe as we know it today. In conclusion, while the discovery of these 6 massive galaxies challenges our current understanding of galaxy formation and the early universe, it also represents a major milestone in our quest to unlock the secrets of the cosmos. By pushing the boundaries of scientific knowledge, such discoveries pave the way for future breakthroughs and expand our fascination with the vast and intricate tapestry of the universe.